Okay, good morning class. So yesterday we were out of electricity, we did the second column as well. Today we said we're going to look at the problems that you had in the first column and the second column, not so? So, in the first column, out of exercise 4.3, is that it? First column out of exercise 4.3.
So I just looked into it and she came close to me.
Okay, then I was wrong. Okay. I thought we only work in maths. Right, people, so 4.3, number 1, any issues there? Sorry? Okay. Just hang on. Number 1, K. I don't see a K, eh? Right, let's check on further down. K. Oh, here's it. K and L. Any other problems in the first column? Why did I ask that? Just hang on. Don't tell each other what to say. Say L, say L. So you're saying K and L, no? Just hang on. And G, okay. There's the first period of the morning, so a bit slow. L and H. Right. G, not J. And J. Okay. That was exercise 4.3. Is that from from the alternate and from the sums that was initially given? Sorry. Is there any other problems with regards to this exercise? Okay, I know you guys are leaving all past, no? So you are hoping to give me enough work so you don't have homework. What's going to happen now is, if you leave before I get to literal equations, please watch the video later on. You see how I did literal equations? And then you would have to do for homework exercise 4.4. In number 1 you do the first column, you do number 3, 5, 7 and 9. So you're going to do the odd numbers, but from number 1 is only the first column. Okay, that's our homework for tomorrow. Again, if you are called out before the lesson is over or before I get to that, just watch the video. I'll do the examples in the video and then you should be able to do number 1, the first column, number 3, 5, 7 and 9 from literal equations 4.4. Okay. Any other problems with this exercise? Okay. It's important that you guys tell me, no? So that whoever watches this video later on probably would have the same problem that you have. Okay. Alright, so Let's do this. So the first one in K, we have to factorize the denominators. That are going to swap around, the sign's going to change. That are going to swap around, nothing's going to change. So that would simply be 2 over the trinomial x and x, 4 and 2, minus plus. Change, swap that around, becomes positive. 5 over x minus 4 equals 3 over x plus 2. What's my LCM here? Let's align this board here. So what's the LCM there? So remember, this sum carries a minimum of 5 marks, no? So it's quite a bit of marks involved here. So LCM is going to be x minus 4, x plus 2. So, did I give you notes on this? No? Let's first factorize the denominator LCM. What's my restriction here? X can never be equal to 4, and x can never be equal to negative 2. This is coming from there and there, or there and there, doesn't matter. Okay. So, what is the first fraction shorting to get the LCM? Nothing. So, this one multiplied by 1. So, it's 2 times 1. What is that denominator shorting? X plus 2. So, the numerator must also be multiplied by x plus 2. Again, don't multiply it out immediately. Okay. What is that shorting? X minus 4. So what do we do now? We can do the brackets by multiplying. So we have here 2 plus 5x plus 10 equals 3x minus 12. X is one side, numbers the other side. So it's going to be 5x minus 3x equals negative 12 minus 2 minus 10, which is negative 24. 2x divided by 2 both sides. Therefore x is equal to negative 12. Okay. Is that correct? Just let me know if I'm getting the sum wrong according to the textbook, and I'll try and check where I'm going wrong. Okay. Who asked this question? Where did you go wrong, Michael?
Sir, I said negative 5 over x minus 1.
So you swapped this around, but you didn't change the sign. Okay, good. Next person, where did you go wrong? You didn't swap, so your LCM was much larger. Yeah. So always try and write it in standard form. Descending powers of x. It will help a lot, okay? Let's carry on with the lives. Oh, we can keep this here. Take this off. L. So again, swap that around. Swap that around is going to be, the sign is going to change there. So it's x over x minus 3 plus 6 over x squared minus 3x. And what can be done there? Common factor of x. So it's x into x minus 3 equals 1 over 1. What's my LCM here? LCM x into x minus 3. What's my restriction? X can never be equal to 3, or x can never be equal to 0. That's all. So what was the first fraction we multiplied by to get the LCM? X. The second one? 1. The 1? X into x minus 3. Okay. X times x, of course, is x squared plus 1 times 6 is 6 equals, again, I'm multiplying straight up. Do not. Later on, you're going to have problems. There's x into x minus 3. Just multiply out, I get x squared plus 6 equals x times x is x squared minus 3x. Again, x is on one side, numbers on the other side. Okay, so the x is cancelled, so it's going to give you Negative 3x is equal to 6. Divided by negative 3 both sides. Cancelled, so x is equal to negative 2. I think that's how we did yesterday. Sorry? You had to do it in class. So who asked this question? What's wrong with you? So your mistake here? Yeah.
Yes.
So you swapped it around, did you change the sign? No, so make a note there. That y minus x will always be equal to negative x minus 1. You swap it around, so you see that's the same mistake you made in the previous sum. So watch out for that. It's a common made mistake. Okay. You okay with that? H. Right, again, you must factorize the denominator. Difference of two squares, again trinomial. See how important trinomials are. So it's going to be minus 3 plus 2 plus difference of two squares, x plus 1, x minus 1. And trinomial again. It's going to give you 2x times 3 is 6. X and 1 minus plus. So what's my LCM here? From the first denominator is going to be 2x minus 3, x plus 1. The second denominator, x plus 1 is accounted for. I'm shorting x minus 1. The third fraction, I got 2x plus 1 is not accounted for. However, x minus 3 yeah, I made a mistake in factorizing the denominator. Okay, I'm realizing now the sum is fairly large. I made a mistake. Late. Okay, so it's going to be 2x and 3. So we're adding our factors. There we go. That's my mistake. I must also go back and learn my trinomials. You see? Restriction. What's the restriction here? X can never be equal to 3 over 2. Or x can never be equal to negative 1. And x cannot be equal to positive 1. Okay, for this one here it was 3 over 2. For that one is minus 1, plus 1, 3 over 2 and 1. Alright, so what is the first fraction shorting? Well, the denominator is shorting. So it's 1 into, this must be multiplied by x minus 1. The top also x minus 1. This one here, this is shorting 2x minus 3. And this is shorting x plus 1. So you multiply the numerators by the same thing. Okay. The sum is a bit busy, so this is technical. So as you see, this denominator is shorting x minus 1. It's x minus 1 plus 2 into 2x minus 3 equals 3 into x plus 1. Okay? So again, we get rid of the brackets, we multiply out. So it's going to be x minus 1 plus 4x minus 6 equals 3x plus 3. So what do we do now? X is one side, now sides. So we got x plus 4, x minus 3x equals 3 plus 6 plus 1. So that's going to give us 5 minus 3 is 2x is equal to 9 plus 1 is 10 divided by 2x is equal to. Okay, any issues there? Did I give you a test back? Did I give you it back? Quiet people, because you're happy. Yeah, yeah, it is. I'll give it now. Okay. Now people, you guys understand? Who asked this question? Me, who's me? Right, what was the problem here? You factorize here wrong. Okay. So you and I should be watching the trinomial video. Okay. Anybody else? You see, if you're going to factorize wrong, then your LCM is going to be very large. Not so. Then you're going to go into x to the 3s and x to the 4s. No? And you multiply. Okay. Anybody else got this one wrong? Jay? I'm working for my money today, you say. Give me a lot of work. Right. Again, the denominator need to be factorized so that the round sign will change. As you can see, it's a positive, changes to a negative. So it's x plus 2 plus 3 over x minus 2, x plus 2 equals negative 2 over x minus 2. So what's your LCM here? LCM. X plus 2, x minus 2. So this must be multiplied by x minus 2. This must be multiplied by 1. This must be multiplied by x plus 2. Okay. So here it's just a matter of solving for x. So it's x minus 2 plus 3 equals negative 2x minus 4. X is one side, numbers the other side, so it's x plus 2x equals whatever lies on that side of the equal sign. I write that first. So it's minus 4, bringing negative 2 over, becomes plus 2, minus 3. So that's simply going to give you 3x. Negative 4x plus 2 is negative 2. Minus 3 is negative 5. No. Yeah, negative 5. Divide by 3. Therefore, x is equal to negative 5 over 3. Is that correct?
Yeah.
Alright. Who asked this question? Who? Me. Okay, who's me? Alright. Where did you go wrong? Me. Sorry? This one here? This one here? Yeah. So you didn't, when you swap this, did you swap it around number 1? Did you put the negative here? Okay, so read for me your first line you have. Yeah? You didn't write 2 here, negative. You wrote negative 2. But you got negative 2 here. Sorry? What? Mistake. But you see your mistake. I don't know where you made your mistake. Okay. So you used, I can't hear you. You're not willing to speak a little louder. Okay. But thank you to me for asking the question. Anyone else have no issue here? Okay. Right. The last one of this type. G. Again, factorize the denominator here. Common factor of 2. So it's 2 over x minus 2, x plus 1. Minus 2 over 2 into x plus 2. Plus 1, sorry. Equals 1 over x plus 1. You all agree that 2's can cancel in that second fraction? Can't it? Why not? Of course. Can I cancel it? I could have cancelled it. But most of you didn't know by the sound of it. Okay? Okay, so let's play it as it is. Because I didn't, by cancelling that, you had made the LCM a bit easier. Okay. But okay, you guys did it. No problem. So what's the LCM here? 2 into x plus 1, x minus 2. You all agree with that? Okay. What's my restriction? X can never be equal to 2, or x can never be equal to negative 2, no? No, 2. Okay, you guys okay with that? So what must the first fraction be multiplied by? 2. So it's 2 into 2. What must the second fraction be multiplied by? X minus 2. So it's 2 into x minus 2. What must this fraction be multiplied by? 2 into x minus 2. So times 1 is remains 2 into x minus 2. Okay? You all understand? From here it is a matter of solving for x. So 2 times 2 is 4, minus 2x plus 4 equals 2x minus 4. X is one side, numbers the other side, so it's negative 2x. I'm keeping on that side, you bring 2x over. Comes negative 2x equal to negative 4 minus 4 minus 4. And that's going to give you negative 4x equals negative 12. Divide by negative 4 both sides, therefore x is equal to 2. Is that correct? Who asked this question? Yes? When you brought this 4 over. So when you brought that 4 over, you wrote minus 4. Correct? But this one you wrote as plus 4. Why can't a girl like you then? Huh? Say something wrong with your place. Now we understand. Okay, but you guys understand? Anybody else had a problem with this question? No. Yes? Yes, yes. What's wrong? Right, so at this point we're looking at is it literal equations? Yeah. Literal equations changing the subject of the formula. So literal equations changing the subject of the formula. Here we are told we use letters as coefficients and variables in a literal equation. Okay. Formula can be regarded as literal equations. For example, a is equal to pi r squared. Well, which formula is that? A is equal to pi r squared. The area by circle. Okay, we did this last year. So we say a is equal to pi r squared is the formula for the area of the circle with a radius r. We call a the subject of the formula. If you say a is equal to something or y is equal to mx plus c, y is going to be the subject of the formula. Okay, alright. Steps to change the subject of the formula. Step 1. Get all the terms of the variables you are solving for, or the new subject, to one side of the equation. As we normally do, x is one side, numbers the other side. Okay? And step 2, solve the equation for that variable. So write those 2 steps down on the side of the first example, which is qx is equal to mx plus q. Okay? This is on page 77. Sample 1, page 77. Right, so what's the first thing we need to do, people? First step? Get all the terms of the variables you are solving for, or the new subject, to one side of the equation. So that's your first point, your first bullet. And secondly, solve the equation for that variable. Example 1. We are asked to make x the subject of the formula. Question is, you write the 2 points down. You should write it down. Nice. Alright, so step 1, get all the terms of variables. So in other words, you're going to get all the x's on one side of the equation. Not so? So we're going to move mx over. So move it over quickly. So what is going to read now? Qx minus mx equals. Can I subtract qx and mx? Why not? It's unlike terms, not like. Now what do we do? Qx divided by x. Adding. So you got q minus m is equal to p over x. Did I make x the subject of the formula? No. Common factor, right? You guys are looking in the book. Nice. Got a common factor of x. Then what are we left with? Q minus m equals p. So I'll get you x on their own, on its own. Divided by q minus m. Both sides. It's gone. So x equal to p over q minus. Okay. Any confusion here? No? Let's look at example 2 on page 77. The question says make R the subject of the formula. Make R the subject of your formula. So write that down, and the reference is example 2 on page 77. Okay. So what's the first thing we need to do? The first step? Get the terms of the r on one side and all the other variables on the other side. Not so? But if you need to look at making lowercase r the subject of the formula, can I just move that over? No, it's bounded by the brackets. Not so? So what are we going to do here? What can we do? Difference of two squares. Let's see. So it's pi into r minus r, r plus r. Now what? That's not going to work for us. Sorry? Square root. Is that what you're saying? Okay. We put the square root here and there. How's that going to help us? You can think of it like this. If a was 2 equals pi into 6 minus r squared. If that was the sum. Then it's 5 is a number, it's 3,14. So let's make it 3. If that was the sum and I asked you to solve for r. Times 3. 18 minus 3r squared. Then what? Take the 18 over. So it's 2 minus 18 equals negative 3r squared. Then I divide by negative 3. Not so. So r squared is equal to 16 over 3. Then square root. Not so. Having that in mind, what's going to happen here? Multiply pi. So do your thing. Multiply pi. So it's going to be pi r squared minus pi r squared. Then what? Then take pi r squared over. Not so? Not that one, okay? This would have been the same and easier. But you want this one? So what is that going to be? A minus pi r squared is equal to negative pi r squared. Okay. Now what? Divide by negative pi both sides. So that's going to cancel. So r squared is equal to a minus pi r squared over negative pi. Now what? Now what we do? Negative, no? Sorry. Negate. Yes. Now what? Square root. Normally we go plus and minus, but not in this case, because your radius is a length, and your radius can't be negative. That is going to be r is equal to the square root of. People, if I swap this around, what's going to happen? We've got a minus pi r squared. If I swap this around, the negative is going to come out, not so? Then what can happen? Negatives cancel. Can you see that? So that means you say, if I swap this around, negative comes out, it's cancelling out, the denominator is negative. So you got pi r squared minus a over pi. But if you had left it like this, you would have still gotten the full marks again. Okay? Do it again. Huh? Yes, okay. So the question says make r the subject of the formula. So what do I do first? Multiply out, get rid of the brackets. So a is equal to pi r squared minus pi r squared. Now what do I do? We need to isolate the lowercase r. So what do I do is I take this over the equal sign.
All grade 10 History girls, can you please come down to
minus
the foyer now?
pi
All grade 10 history girls, can
r
you
squared is
please
equal
report
to
to the
negative.
foyer now? Thank you.
Okay, now what? Divide by negative pi percent. So that cancels. So r squared is equal to a minus pi r squared over. Now what do we do? Yes.
How does that pi not cancel out with negatives?
Who can tell her? She's asking why does this pi not cancel that pi? Is that what you're asking? Sorry, no, not over r squared. If you have negative pi r squared over negative pi, that cancels. What? There's two terms on top because of this minus. Negative or plus. Okay. Now what do we do? Square root. If we introduce square root normally, plus minus. Since we're busy with radius, not going to make a difference. The radius will always be positive. Okay? That is the square root of. As I said before, you could lift it like it, or if you swap this around, a negative comes out. Not so making that negative or cancelling that negative. So it will be the square root of pi r squared minus a over pi. Okay. Now that we do history. Aren't you supposed to go? Oh, you want to watch? This is better for you. Okay, nice, nice, I like it. Oh, now you're going. I just have to keep quiet. Right. Don't forget I gave you guys homework, no? People, let's look at example 3 on page 40 and page 77. Example 3, page 77. Solve for x. Alright, so write down example 3 quickly. Okay. So what we're going to do first here? Sorry? LCM. And what's your LCM here? LCM is AB. What's my restriction? What's your restriction? A can't be equal to 0, yes? And B can't be equal to 0. Otherwise the sum will be undefined. Answer? So the question you should be asking yourselves, what must this first fraction be multiplied by? What must this first fraction be multiplied by to get the LCM? B. This here? A. This here? AB. You will understand. So what would I have? B into x, so x into b plus a into x equals ab into now what? What do we do now? You multiply this in. Not so. So it's going to be bx plus ax equals ab. Now what? Put the common factor off. Take out your common factor. If we take out x as a common factor, what are we left with? B plus A is equal to AB. Now what? Sorry? You add both sides by B plus A. So of course that cancels. So x is equal to AB over B plus A. Something like this worth minimum 4 moles. You guys understand? Okay. Any questions? Any questions yet? No? Okay. So now we're going to start with exercise 4.4, the first column. You see that first column there? So what I want you to do is, you answer those questions and I'll call you up now one by one to see what is going on. Okay. We're not going to pause the video. Alright, so let's go through the first three. Another bell rang. So first we take it over. So it will become AX is equal to C plus B. Divided by A. So X equal to C plus B over. All agree with that? Let's look at C. So it will be R minus Sx is equal to T. We're going to solve for X, make X the subject of the formula, we take that V over. So negative Sx is equal to T minus V. Okay, so I divide by negative S both sides. That cancels, so X is equal to T minus V over negative S. Or, I can swap this around, which is V minus T over S. Yes? So R, okay, instead of a V it's R. Okay. And then E, as you see we've done with that one as well. So E, I'm going to get that on its own, so I take that over, whilst I get P on that side. So it's X over 2 is equal to M squared minus P. If you had gone the other way around, it would have been P minus M squared is equal to negative X over 2. It's the same. What do I do now? How do I get X on its own? Times by 2. If you had gone the other way around, at this point you would multiply by negative 2. So X equal to 2 into M squared minus P. Or, it's 2M squared minus 2. Okay. Any questions there? People, don't forget the homework. Whether it's every day. In tomorrow's lesson, we will look at the test that you wrote yesterday. I just forgot at the beginning of the lesson to give it to you. Okay. Good morning, class.